In the last video, we basically figured out how to find the vertical stretch when we were given the x-intercepts and the y-intercept. Now, the question I posed was, do we just, besides the x-intercept, do we always just need the y-intercept to find the vertical stretch? No, we can use any other point other than the x-intercept to figure that out. So let me do that with an example for this video. So here's an example. A parabola has x-intercepts -2 and 6. It goes through the point 1, 45. So x is 1, y is 45. Find the vertical stretch and write the equation in factored form. Now, one good thing to do always is just always draw a sketch. When in doubt, draw it out. So let's draw a quick little sketch of what this looks like. So we have our y-axis here. We have our x-axis here. Okay. So we have our x-intercepts, which are -2, which is -2 here, and then we have 6, which is, let's just say that's over there, and we have a point which is 145. So let me just say that this point right here is, so this is 1, and let's just say that's 45. And what we know is that a parabola simply goes through that point. That point does not mean it's the vertex or anything. It just means that it just simply goes through that point. So if we want to find out, remember, a good thing to do is always find the axis of symmetry. So the axis of symmetry is x equals p plus q divided by 2. So that's -2 plus 6, so -2 plus 6 divided by 2, which is equal to 4 divided by 2, which is equal to 2. So our axis of symmetry would be somewhere at 2, right? And we know our vertex lies on this axis of symmetry. We just don't know where, but we know that it lies on this axis of symmetry. So let me draw a sketch. So I know that it's going to go through the x-intercepts, and I know that it's going to go through this point, 145. And this time, this point is not the y-intercept. It's a totally different point. So let me just sketch that. So I have, it goes, and I know my maximum is going to be right there because it has to lie on the axis of symmetry, and then it's going to descend, and it's going to go through there, and that's basically what my parabola is going to look like. I know it's not the smoothest parabola, but you know, my sketch is not to scale. But anyways, you get an idea of what my parabola is going to look like. So our goal here is to find the vertical stretch. How do we do that? So once again, we have the x-intercept, so we can express this in terms of the factored form. So y equals a, and since it's -2, this is going to be x plus 2. And since this is +6, this is going to be x minus 6. So we want to find what a is, in other words, the vertical stretch. So how do we do that? Remember, we need a point other than the x-intercepts. And what other point do we have? Well, we have this one right here, 145. So 45 is y and 1 is x. So 45 equals a times 1 plus 2 and 1 minus 6. So 45 is equal to a, this is 3, and this is -5. And basically, let me just write this here, 45 is equal to 3 times -5 is -15. So it's going to be -15a. And finally, a is going to be 45 divided by -15, which is equal to -3. So my vertical stretch is 3, and the negative tells you that there's a reflection across the x-axis, which makes sense. We can see that it's facing down, so there is definitely a reflection across the x-axis. Now the second part of the question is write the equation in factored form. Let's just do that. Let's write the equation in factored form. So it's y is equal to -3. We've said this is going to be x plus 2, because that's -2. It's going to be opposite here. And the other one will be x minus 6. So this is how you write it in factored form, and we're done. All right, so in the next video, I'm going to go through an application of all the parabolas. So far, we've just been looking at formulas. Let's actually do something fun. So in the next video, I'll show you one quick application of how we can use all of this factored form into a real-world application.